transport layer, what is the goal of transport layer, and what is the objective of this lecture? It's a group of lectures. We need to understand principles behind transport layer services. So basically, there are four important objectives once you design a transport layer protocol. Obviously, we know that there are two types of transport layer protocol in our TCP/IP protocol suite. One is UDP and another is TCP. We'll be seeing both of them. So multiplexing, demultiplexing, that is the most important thing, because as little bit we have understood up till now that we do have only one IP address, one LAN card, but we at the same time run many network application. So how to multiplex and demultiplex the different data streams which are going through that LAN card. That is what we are going to understand first of all. Then if we want to transfer data in a reliable manner, we need to develop some rules and some regulations for that. As we know that the underlying internet is unreliable, provides no guarantee. So if you want to have a reliable data transport, how we can achieve that? Flow control, because once we are talking about internet scale protocol, so you might be having two machines. One may be having good computing power and good bandwidth, other may not be having that thing. So how to regulate the flow of the fast sender according to the receiver's capacity? That is what we're going to see in flow control. And congestion control, that's an interesting aspect. Congestion control is entirely a network layer issue, but around 1887, when there was an internet shutdown due to internet congestion, the decision was taken to shift this particular duty of network layer towards the end. One more thing, a transport layer is entirely implemented at the end host. It is not implemented at the routers or in the core of internet. So routers and switches work up to data link layer. Like if we are talking about layer 2 switches, they work up to data link layer. If we are talking about layer 3 switches and router, they work up to network layer. But transport layer is a protocol which is entirely implemented at the end. And then this decision was taken to, shift the congestion control mechanism from network layer to the transport layer, because the reason behind that is end hosts are ultimate reason of congestion, because they are pushing data into the network. So if we somehow can send some signal, implicit or explicit, from the network to the end host, that network is getting congested, and if somehow end host can regulate accordingly, then our work is done. And that's what we are going to see in the congestion control part of the transport layer. Basically, we'll be going to see three aspects: UDP, which is connectionless transport; TCP, which is connection-oriented transport; and in connection-oriented transport, we'll be seeing TCP flow control also, and then TCP congestion control. Transport layer services and protocols. It provides logical communication between application processes running on different hosts. As I told you, transport protocol run in the end system. So what sender side is going to do is going to break the messages into transport layer protocol data units, which are known as segments. And then these segments are going to be passed to the network layer. Receiver side is going to reassemble the segments into messages and passes the messages to the application layer. And as we know that there are more than one transport protocol available to application, depending upon the requirement of the application, quality of service requirement of the application, internet protocol should provide you two protocols, TCP and UDP. So as I told you that it is running entirely at your end host, and it gives you a logical end-to-end transport. TCP is reliable in order delivery, and it gives you congestion control, flow control, connection setup. And for having a reliable in order delivery and provide an illusion of a connection across the unreliable internet, it provides you an illusion of a connection uh, and gives you congestion control and flow control in addition. And to have a TCP, we need to have a connection setup. A little bit of TCP connection setup we have already seen when we were seeing the HTTP protocol. Unreliable unordered delivery, UDP, is again a next limit where it is just a no frills extension of best effort IP. But in these both protocols, services which are not available are delay guarantees and bandwidth guarantees. So yeah, it can, when you talk about TCP, it can abstract all the problems or hide all the problems which are going to be there due to unreliable internet. Uh, and UDP is not going to provide you anything extra. It is just a no frills extension of best effort IP. But both these protocols cannot provide you delay or bandwidth guarantees. An important aspect is multiplexing and demultiplexing. Multiplexing is done at the sender side. Gathering, as I told you, that every application has to open a socket, and application writes data to that socket. And then all these data streams from different sockets will be encapsulated by transport layer header, and then will be multiplexed through one LAN card. What is happening at the receiving end? Demultiplexing. Once the packets are received or segments are received, they are demultiplexed to the different sockets running at that machine. So if we switch to the whiteboard, what is going to happen is, suppose there is a machine here, machine M1, fine, and it is running, say, 3 applications. So say application 1, application 2, and application 3. Fine. So all these 3 applications would be writing data to these sockets. As I told you, sockets are just like a pipe or a file where you can write data. Now, data from all these sockets should be multiplexed to one LAN card and then sent out. When reply will be coming for this application, again using the socket identifiers, the data will be demultiplexed towards these different applications. So this is what is the most important, you can say, role of transport layer. And because we have done operating system also. Now, if I say that port, which we know that every socket is going to have a port number, and obviously the socket will be bind with a port number and IP address. So if a machine is there, its IP address is suppose IP M1. So these 3 sockets will be running on different ports, but yeah, IP would be same. So if I say that port, which is just a number, or a, you can say, the identifier of a buffer, which is socket, in another term we can say socket as a buffer. So if I give you a comment that port is nothing but a virtualization of LAN card, what are your comment? If I give you comment, the port is nothing, the transport layer port is nothing but the virtualization of your LAN card, what are your inputs regarding this? Anybody? Yeah, Karimullah, are you there?
Yes, sir. Can you repeat the question? My network is not stable.
I'm saying that if I say that the port number which is associated with every application running on a machine, port number or port, transport layer port, is nothing but the virtualization of your LAN card. Is this statement correct? Incorrect? What are your comments regarding that?
Yes, sir. I think it's correct.
Abhigyan?
Yes, sir, I think so. You can say that.
So, so what is the reason behind your uh, thinking? Why you are saying that port can be thought of as a virtualization of LAN card? What is the abstraction which is virtualization of your processor? Yeah, Karimullah.
No idea, sir.
I have taught you operating system.
Yes, sir.
Abhigyan,
Sir, I don't remember.
what is the abstraction of your RAM? Karimullah?
So,
Okay, let
what do
me.
you mean by abstraction of RAM?
That's what happened when you forget everything from the previous semester. Now let me elaborate this. Suppose I have got 4 GB of RAM. Okay, can I run an application whose size is 6 GB or 8 GB? Yes, I began.
No, sir, not like that. We used virtual memory management
You
in that.
use virtual memory.
Yes, sir.
Then what happens?
Uh,
What is virtual memory?
so the physical addresses were converted into uh, logic.
क्या पढ़ा है तुम लोगों को?
Yes, sir, we can run the 8 GB process.
How?
Sir, so we will like passes few processors which are required to run at the current time, and we will remove them from the memory after executing them, and we'll bring on new processors.
So, Omkant, you are trying to say that this 4 GB is getting reused by different modules of this big process. Fine.
Yes, sir.
So, which is not getting utilized at this particular moment will be swapped out
Yes, sir.
in hard disk, and whatever you utilize will come back. Okay.
Yes.
So the same 4 GB of memory is getting used by many processes. Even your operating system is nowadays 16 GB, no?
Yes, sir.
So what is happening? You are not thinking you are having 4 GB of memory. You are thinking you are having from 0 to some large number whole virtual memory, and every process will be having the same virtual memory. Remember?
Yes, sir.
And this virtual memory is getting mapped to the physical memory as and when this process wants to run. So your same physical resource is getting utilized again and again by different processes using the abstraction of virtual memory. Now, what is the abstraction for the processor? Now, anybody can answer?
Sir, I'm not sure if you are like about the answers. I think you want to answer that, sir. We can run as many processes, and every process will know that it is currently running on the CPU.
Process is the virtualization.
Yes, sir. Okay. Yes, sir.
Remember the name of the lecture. Remember? It was CPU virtualization. Remember?
Yes, sir.
And what was the abstraction? Process, which is just a logical thing. Yes or
Yes,
no?
yes, sir.
Which has process control block, which takes the processor register, the files which process has opened. When it is not running, it is having a snapshot of the system with itself. Remember?
Yes, sir.
So process itself is a abstraction which provides you processor virtualization. So there may be 4 or 2 or 8 processor depending upon you have a dual core, quad core or octa core, but there would be many number of processes. So you give a abstraction. That's why when you want to run a program, you need to create a process. Remember?
Yes, sir.
Abhigyan?
Yes, sir.
What? Yes, sir. Now on the same lines, you can say that socket or a port number is virtual is a virtual LAN card because you have one LAN card, fine, which can transfer data out in serial manner one by one. There are many applications which are running. So at a time, only one application data can transfer through this LAN card. So when an application is not using or the LAN card is getting utilized by any other application to transfer the data of any other application, whatever data is getting created by, suppose A1 is right now using the LAN card physically to transfer the data, and A2 is also generating some data. So A2 data has to be stored somewhere in a socket. Yes or no? But application should not get this idea. That's what you create so many processes, you have less number of processor, but you don't get any idea whether your process is running or not. It may be waiting somewhere in ready queue or in somewhere else. So on similar lines, port is transport layer port is virtualization of your LAN card. Any doubts, any questions? Aman Singh, Tanmay, क्या विज्ञान मन नहीं है पढ़ने का?
No, sir, like,
हाँ
याद
बता।
नहीं आ
हम्म,
सर, याद
बोलो।
नहीं आ रहा था, याद आ गया।
यार याद होने वाली बात नहीं है ये सब. Logics cannot be crammed up, okay? Feeling cannot be crammed up. If you are not feeling the subject, why we have studied operating system? And the biggest thing in operating system is the process, which is CPU virtualization. And that particular concept, this is a concept which cannot be crammed up. Got your point? Got my point? Anyways, so what is going to happen when an application, suppose two applications are running, so there would be a relationship between socket to socket. Obviously, data is going to transfer from LAN card to LAN card, but at a logical level, there would be a connection between socket to socket. Suppose I say that P3 is writing application process P3 is writing to application process P1 in host 2. So it's like P3 will write the data in its socket. Once it has written data in its socket, this is the duty of transport layer and other layer to transfer the data to the socket of P1, and P1 will read data from its own socket. So this is how multiplexing and demultiplexing is provided by the transport layer. How demultiplexing works? Each datagram has source IP address and destination IP address. As we know, these are the two, SIP and DIP are there in the IP header field. Each datagram carries one transport layer segment, and each segment has source port and destination port number. Just for your revision, so there would be what? A packet will be generated at the application layer. Suppose it is a HTTP packet, so HTTP header would be there. Then HTTP data. At transport layer, it will be encapsulated by transport layer header. So source port and destination port would be put. At network layer, it will be encapsulated by network layer header. Source IP and destination IP would be there in the network header. Finally, it will be encapsulated by Ethernet header, and source MAC and destination MAC would be there. So this is how the whole encapsulation takes place when you transfer data from application to out. When this data reaches to the destination, packet header by header, headers are removed and application gets the data. So how this is happening? Each datagram carries one transport layer segment, and each segment header contains source port and destination port. What host is going to use? First of all, IP address will be used by machine to accept the packet. Within that machine, which application to send will be decided by the port number to transfer the segment to appropriate socket. Because all the sockets in that machine would be having same IP address. If it is having one LAN card, all the sockets is going to have same IP address, but fine. If it is having one LAN card, but which socket is for which application, that is going to be decided by the port number. First of all, UDP. So to just writing in some language. It's a Java language. You can create datagram socket by writing these particular statements, and you can provide the port numbers when you create sockets by Java. In C and in BSD Unix, there is a system call known as socket. We'll be seeing that. So you can create socket by using this socket system call. Obviously, if Java is running on Linux, this particular statement from the package will be translated into this socket system call. So when creating datagram to send into UDP socket, you must specify the destination IP address and destination port number. When host receives a UDP segment, checks destination port number in the segment and directs UDP segment to socket with that port number. IP addresses with different source IP address and or source port numbers are directed to same socket. This is connectionless demultiplexing. Let me explain it further. Suppose there is, let me take the SNP. Suppose there is a server, UDP server, which is running a server application as process P3. The server application has opened a socket, this yellow color thing, and server IP address is C. Suppose this socket, once you create the socket, you give the port number 6428. So a socket will be identified by the IP address and its port number. 6428 is the socket number where this server is running, P3 server is running. Suppose P2 want to send a message. So P2 will be at the transport layer, will be sending its source port number, means the port number associated with this socket, which is created at machine A and P2 socket. Source port is 9157, destination port would be 6428, source IP would be A, and destination IP would be C. Now this particular packet will come to the machine using the destination IP address C. Packet will be accepted. Using the destination port this, packet will be redirected to this socket 6428. Now P3 wants to reply. P3 wants to reply to P2. How it can reply? Because this segment which reaches at P3 would be having source port number. So when P3 creates a reply, so in source port, it will be having its own port, but in destination port, it will be writing the port number which was used as a source port number by P2. And in this way, the reply can be generated. Source port provides the return address. Similar here. So the here interesting fact is that because you are not trying to maintain the state of any client which is attaching to you, you are providing a connectionless demultiplexing, you are required to have only one socket at the server end. And everybody would be giving that same socket. Just a minute. आशीष क्लास में है अभी. अभी हो रहा है, ठीक है, हो जाएगा तो बताएंगे तुम. अकाउंट नंबर तो तुम्हारे उसमें इनवॉइस में नहीं था कि किसमें बिल जनरेट कर. पंकज भैया से बात करो. अजीब काम करते हो तुम. Fine. So now P1 similar. The P1 wants to send packet, will be using its own source port number, which is 5775. Destination port will be 6428 of this socket. P3 wants to reply at the time of reply, that destination port will become the source port of P1. In this way, in connectionless demultiplexing, only one socket is sufficient to handle the things. Now let us move further. Connection oriented demultiplexing. Please be very careful when we have a connection oriented demultiplexing or TCP, because there would be a situation, because you want to give a reliable connection. So if packets are getting lost, you need to keep a record of that, how many packets have been received in order, how many packets are out of order. So a single socket is not able to handle all the clients. So what is going to happen, for different clients, there would be different sockets which are going to be open. And TCP socket will be identified, TCP socket at the server end will be identified by source IP, source port, destination IP, and destination port. And receiver host has to use all these four values to direct segment to appropriate socket. So even if three things are same and one is different, that would be a different socket. Server host may support many simultaneous TCP socket. Each socket will be identified by its port tuple. As example, web servers have different sockets for each connecting client. And in case of non-persistent HTTP, will have different sockets for each request. Now, just to elaborate this, just please be with me, it's important. What is going to happen? Suppose I say that there is a web server. Fine. So that web server program would be running on web server, and the server program has opened a socket. Please be with me. And this socket would be bind with one IP address. Suppose I say that this IP is IP of server, and one port number, because it is a web server, it is bind with port number 80. Now let us take different scenarios. Suppose client 1 wants to connect to this web server. So client 1 will make a request with the source port, suppose port of C1, any source port, destination port 80, source IP is IP C1, and destination IP would be IP of server. Now this particular request with these things will go to here at the server. Server will see the network header, will see, okay, IP address is matching, will receive the packet. And destination port is matching 80. Okay, I need to transfer this request to this socket. Because this is the socket which is running on port number 80. Now here comes a big catch. Here comes a big catch. Please be with me. So as and when this request, because this request is destined for port number 80, means socket which is bind with 80 port number. Using the destination IP, the packet is accepted at the network layer. When it is transferred to the transport layer, the packet is transferred to transport layer. It has to go to port this socket which is binded with 80. Now, if you connect these two sockets at this moment, suppose client socket and server socket, if you connect at this moment, this socket will be engaged for client number C1. And now other client C2, C3 will not be able to connect. So what you will do, as and when you get a request that a client wants to connect, the server will create another socket. And this socket will be identified by 4 tuple. And that 4 tuple are source IP, which is IP C1, destination IP, which is IPS, source port, port of C1, and destination port, obviously 80. This socket will be identified by these 4 tuple. And C1 socket will be connected to this new socket which has been created. And the original socket is now free to listen to connections from C2, C3 and other clients. When C2 want to connect, now suppose C2 want to connect, C2 will send request to this green socket again. A new socket will be created. And what is the identifier of this new socket? Source port would be of port number C2. Destination port 80. Source IP of C2. And destination IP would be IPS. And in this way, these two sockets can be differentiated. Because now the identifier is not by 1 or 2 field. The identifier is made up of 4 tuple. Now suppose at this point of time, C1 machine wants to have another connection to this server. Now what will happen? Anybody can tell? This connection is going on. This first connection is going on, and at the same time, C1 wants to have another connection. What will happen? Yes, Abhigyan.
Sir, another socket will be created.
Another socket will be created. What is the identifier?
Sir, right now C2 is joined.
C2 is there, yes.
Sir,
C2
so
is there. C1 initial is there. Just write down. Be mechanical. Source port would be port of C1.
Yes, sir.
But this port of C1 will be different from this C1 port of C1. This is the duty of the operating system of C1 machine. Okay. If a port is getting utilized, fine. So
Yes,
you can say C1 1.2. Okay. another port will be given. So if PC1 initially is 85629, so this port will be some 90248, because a port of a machine is already utilized. This machine for another connection, another socket, give another port. So source port will be different. Okay. Source IP, okay, IP of C1, no problem. Destination IP, IP of S. Source destination port 80. So you may see that if we see credential, this credential 80 IPC1 IPS, 80 IPC1 IPS, all these three are same, but this PC1 would be different from this PC1. So you can identify these two sockets. Are you getting my point or not? Up again?
Yes, sir.
So this is what is happening, because for every connection you have to maintain a state. Which packet have been transferred, which packet have been dropped, which packet have been repeated, which packet are duplicate, which packet are arrived out of order. For every connection, because you are trying to provide connection oriented transport, you have to maintain a state at both ends. So you require different socket. Now suppose if I ask you a question, if anybody can answer, say Karimullah, suppose a TCP server is there and currently it is supporting 500 simultaneous connection. How many sockets would be there at TCP server?
Sir, 500
500?
will be connected and rest will be open sockets.
Rest will be open, only one open socket, bacha.
Yes, sir, the 80 port.
The 80 port, not 80 port.
The socket
Once
connected with 80.
one socket, all the sockets are connected with 80 port, bacha. Now 80
Yes.
port is not an identifier, okay? Identifier is this complete. That's what I want to put forward. All these sockets are having port 80, but these sockets are different because now the socket is not identified by port 80 only. The socket is identified by 4 tuple: source port, destination port, source IP, destination IP. Okay. So if you
Yes,
have
sir.
500 simultaneous connection which are already there, you'll be having 501 sockets, 500 for 500 connection and 1 for listening to another incoming request if there are any. Okay. Okay, Karimullah?
Yes, sir.
Okay. So let's move ahead. So the thing which I have described, see there are 3 connections. Fine. And when we have connection oriented demultiplexing, we always talk in terms of connections. That you can see there are 3 connections: P1 to P4, P5 to P3, and P6 to P2. And maybe this P4, P5, P6 can be different processes or can be same process. So you can have one process only which is providing different connection, still you will be having different sockets. Now this is what is going to happen in actuality. Please be with me. Let me take the snip. So let's see what is happening when you have a UDP kind of thing. So both server and client would be having socket system call. Then both will use bind system call. Using bind system call, you can provide this socket, the source port and source IP, or you can just provide the port number and IP. This is the identifier of this socket. You can say when you bind a socket, you give it port and IP. So IP would be of the machine's IP and port any free port which is available. Client end same. And now there is no connection, nothing else. It is just like send to, receive from loop. And finally, the sockets are closed. This is in UDP, connectionless transport. Now, what is happening in TCP? It's interesting. Server, socket, then server will bind the socket with the port number and the IP address. Now, server is listening on this socket, listening on this port number. On the other hand, socket at client, no need to bind. You can use bind here also, but it's not needed because operating system will do that work for you. Provide the IP address of the client to the socket and any unused port number to the socket for this particular connection. Now you send a connect system call. When you send connect, it goes to the listen interface, and as soon as server accepts this connection, there's a lot happening in between. That's a three-way handshake which happens. We'll be coming to that. As soon as it accepts, a new socket is created and server start listening on the old socket for the another connection. And once this accept system call is there, a new socket is created, client socket will be connected to the new socket which is created for this particular connection. And now this socket will be identified by 4 tuple: source IP, destination IP, source port, destination port. And this is how, and then you can send, receive, send, receive. This is the difference between a connection-less transport and connection-oriented transport. I'm talking in terms of system call because you people are well aware about system calls as we have done in our operating system course. Fine. So you can see what you are doing, send to and receive from, when you are saying send to. So you are using server socket where you are giving your own address. Fine. So this is how we use bind. So at the server end, server socket is bind by server's address and server port number. We'll be seeing this particular thing in our socket programming lab. Fine. In detail, that how you can create a socket and how you can send data or receive data from. So when you want to send data to server socket, you have to provide the IP address and port number of server, and then you have to provide your own address and own port number to server so that the whole 4 identifiers can be assigned to this particular connection. Why there is UDP? As we have discussed that there is no need of connection establishment, which can add delay. No connection state is maintained at sender or receiver. It is having very small segment header. No congestion control, and UDP can blast as fast as desired. It is no frills bare bones internet transport protocol. Segments may be, it's a best effort service extension of the best effort service of internet. Segments may be lost, delivered out of order to application. No handshaking between UDP sender and receiver. And each UDP segment is handled independently of others. Please be with me. So this is how the UDP header looks like: source port, destination ports, length in bytes of UDP segment, including the header, and some checksum. If you want to have reliability, you have to add reliability at the application layer. Like in DNS, when you see the DNS header, you see that there is some sequence number in the DNS header just to identify which of this request is for and for which we have to send the reply. When you want to add reliability over UDP, you have to add reliability at the application layer, and you have to have application specific error recovery. It's often used for streaming multimedia application, but nowadays I told you that TCP is equally good after the advent of Dash. So what is UDP checksum? Detect errors in transmitted segment. It's not correcting or doing any action. It is just detecting errors. And if error is detected, that particular packet will not be provided to the application. What sender is going to do will treat segment contents as a sequence of 16-bit integers. Checksum is created once complement segment of segment contents, and that checksum value is put in the UDP checksum field of the UDP header here, 16-bit field. Receiver will be computing checksum of the received segment. Whatever is received, that checksum is computed. If computed checksum equals to the checksum which is given in the field value, no error is detected. If they are different, error is detected. Even if the error is, if they are same, but maybe errors nonetheless, there may be another problem that checksum itself is compromised, something like that. So we'll be coming to that later. But it's a very plain old simple checksum mechanism which is there in the UDP. Note, when adding numbers, a carry out from the most significant bit needs to be added to the result. Suppose you add two 16-bit numbers, the whole header and packet content will be lined up in 16-bit integers. Keep on adding them, and once the wraparound is there, add it again, and then you want to have a ones complement. How do you take the ones complement? You just flip the bits. So if this is a sum, the checksum would be the ones complement. You can see here, and that particular thing will be added into the checksum field. At the receiver end, the packet is recomputed. Fine, value is recomputed. Checksum value is recomputed and compared with the value of the checksum field. If it is equal, then no error is detected. Error may be there. If they are not equal, then error is detected. Now this is most important. It's known as pseudo header. Now just read this slide, because this is the most confusing aspect of UDP and TCP both. We have a concept of pseudo header. We include these field when we are calculating the checksum. These fields are not sent with the packet, because these are the fields which we have actually borrowed from the network layer. So 16-bit UDP total length, 8-bit protocol, whether it's a UDP or TCP, all zeros. So 60 and all 8 zeros, then 8-bit protocol field and 16-bit UDP total length, the source IP address and the destination IP address. These values are included while you were calculating the checksum. And receiver will also do the same. Include pseudo header in the checksum calculation. The pseudo header is not part of the packet. It's not part of the packet. Packet is simply this. Please be with me. It's important. Packet is simply this. Application header, data, and then UDP header. So UDP header is having field, as I shown you in the slide. These are the fields of UDP header: source port, destination port, length, and checksum, and then the data application, then application header and application data. So there is no pseudo header field. But while we are calculating the checksum, we include these fields known as pseudo header: 32-bit source IP, 32-bit destination IP, all zeros, 8-bit protocol, and 16-bit UDP total length. These fields are included while calculating the checksum. And receiver also, when calculates the checksum, includes the pseudo header fields in checksum calculation. Why? That's the question. Why we include these two things? Any answers? Any idea?
Sir, to make sure that it reaches correct destination. Like the IP address may change during the transportation.
No. So this is say I'm giving you 30 minutes. Fine. You can read answer from internet wherever and write the answers in the chat box. Fine. And I'll evaluate these answers as a quiz number 1. Fine. This would be quiz number 1, and that would be evaluated. Open internet, open everywhere. Everybody understood the question. Fine. The time right now is 16 past 16 means 16 past 4. I'm giving you 15 minutes. Fine. So up till 4:35, 4 more minutes. Up till 4:35, you have to give me answers. I'll not evaluate the answers after 4:35. And you have to write the answers in the chat box. Copy paste are not allowed. Okay? Start working. You can go through internet and see the things. Why we need to include these fields known as pseudo header when we are calculating checksum in UDP or TCP. That's what.